Hello, I'm AJ Ragusa from the software engineering team at the Global NOC at Indiana University. Today I'm going to be talking about SciPass, an OpenFlow-based Science DMZ and IDS load balancer. SciPass is an OpenFlow-based Science DMZ. It provides IDS sensor load balancing, fine-grained institutional firewall bypass, and fine-grained traffic filtering. The SciPass architecture during normal operation consists of an OpenFlow switch with the LAN connected on the south and the WAN connected on the north. In the middle is the firewall and IDS sensor cluster. SciPass sends all traffic through the firewall and load balances traffic across the IDS sensors. Balancing across the IDS sensors can be done by two different mechanisms: total bandwidth or by sensor load reported via the SciPass API. When an IDS sensor detects a known good flow, it reports the flow to the SciPass controller. The SciPass controller then instructs the OpenFlow switch to fast path the traffic, bypassing the firewall and IDS sensors, increasing the performance of the flow. This frees up resources on both the institutional firewall and the IDS cluster, improving the overall network experience for everyone. Now let's see a demo of SciPass in action. Our demo consists of a typical 10 gig firewall device. A Brocade MLXE4 with 8x10 gig card is our OpenFlow switch. An IDS sensor, a Grid FTP client on our local area network, and a Grid FTP server at multiple remote sites across the LAN. All traffic is passing through the MLXE, which is in OpenFlow mode, controlled by our SciPass controller. SciPass has been configured so that all traffic is being sent through the firewall and to the IDS sensor. SciPass is also in Science DMZ mode. In our demo, we've configured the IDS sensor to know that a Grid FTP transfer between our endpoint and remote site A is a known good flow. However, a Grid FTP transfer between our endpoint and remote site B is not. Remote site B, however, is not known as a bad flow, so it is allowed to continue through the firewall. To start, let's attempt a transfer of 100 megabytes from remote site B to our endpoint. This transfer is going entirely through the firewall. Also, all traffic is duplicated to the IDS cluster. As you can see, we're approaching 1.1 megabytes per second. If we take a look at our usage graph, the top graph here represents our LAN interface. This is traffic being output to our host. The bottom graph represents the firewall LAN interface. This is seeing traffic coming in from the firewall. As you can see, both graphs line up fairly closely together. This shows that all traffic is traversing the firewall. Because we are transferring 100 megabytes at about 10 megabits per second, it'll take us a while. So we're going to stop the transfer, and now we're going to attempt to do our good transfer. This transfer will allow the IDS to detect signals the SciPass controller, which will then install the fast path flows on our OpenFlow switch. Now that we've started our flow, you can see that there's a slow ramp up of our TCP session. This is because our session started through the firewall. Eventually, the IDS detected it, signaled the SciPass controller, which then signaled the OpenFlow switch to allow the traffic through. Taking a look at our usage graphs, we can see a 9 gigabit per second spike in our LAN interface. However, if we take a look at our firewall LAN interface, we see only a small, brief spike. This is because the flow originates and starts flowing through the firewall. However, the IDS sensor detected that it was a known good flow, signaled SciPass, which then installed the forwarding rules to fastpath this flow. Now we see our flow is running at about 9.8 gigabits per second, and will soon complete. It looks like our flow has now completed, and if we take a look at the peak of our graph, we will see that we hit approximately 9.8 gigabits per second. We can also take a look at our transfer and see that yes, our transfer has successfully completed. Thank you for watching our demo. For more details, go to http://globalnac.iu.edu/sdn/scipass.html.